Hello everyone, and thanks for joining us today. I'm Katrina Schweikert. I'm a product manager here at Blue Marble Geographics, and I'm joined by my colleague, Danielle Karen.
Hello everyone, thanks so much for joining us.
So today we're going to be talking about our academic curriculum, and we're going to kind of dive right in with a little overview of what we'll be covering today.
We have a lot of great information to share with you. I think a lot of the registrants are already using our software, maybe have already accessed our academic labs, and some of you are new to it, so we're happy to introduce it. Blue Marble started this academic initiative back in 2017. We wanted to provide colleges and universities and the academic community an opportunity to deploy our software, GlobalMapper and Geographic Calculator, in a classroom setting with hands-on lab instruction for personal use, for research use, for faculty use, easily, without a lot of preparation, without a lot of extra time that we know faculty and professors don't have. We definitely recognize the role that academia plays in preparing today's students for tomorrow's workplace. And it's very important. I know Katrina comes from an academic background, and my work in sales, we run into academic folks all the time, and the geospatial sector continues to grow very, very rapidly, and it's critical that these graduates and these students have the skills and the know-how to maintain this momentum. Blue Marble Geographic's investment in GIS education is absolutely motivated by our desire to ensure that there's instructions on the fundamentals of GIS, and it's not held back for monetary reasons or because they can't install the software or they don't have time to write the academic labs. We want to make sure that this GIS technology is available to everybody, all students. Our goal is to provide alternative options and awareness to students that are engaged in GIS studies. We have found through the years that the variety of disciplines that now include GIS are growing as quickly as the industry is, and that's great that they're trying to keep up with the industry demand. In the past 5 years or more, well, 2 years that we've been doing this really, we've had over 135 schools and universities use and license our application through this program, and that makes us really proud of the work that we're doing. The classes range from traditional GIS and geography to forestry and freshwater ecology to engineering, and now it's branching off into business classes as well. It's really, really great to see that growth and that interest. So, how does it work? Well, we have a great little form on our website. It'll only take you a couple of minutes. You could potentially even ask a student or a what do you call the helpers in the classroom there these days?
Teacher's assistant.
There we go.
Or,
to fill
graduate
out,
TA. Yeah.
Graduate TA, thank you.
Yeah.
To fill out that form for you, but we do want it to be the professor's information. Just a little bit of information from you about how it's going to be incorporated into your curriculum. We review the applications. We'll reach out to you to say hello and give you some great tools to use. And then we send you the license and you're up and running. We do have a couple of license options. We have a network server license. We have individual machine locked licenses, depending on how you deploy your students, if they're remote learners or in a lab or in a library. We have some options there. And then you could be up and running. It could happen in a day or in a couple of days. We really don't want to take any more of your time. We're trying to keep it very easy. GlobalMapper allows teachers really to focus on the practical application of the spatial technology rather than spending that valuable classroom time teaching students how to operate the software. And Blue Marble is here to support you. So that support includes webinars like this, and we have YouTube videos, we have the academic labs, which is what we're here today talking about.
Absolutely.
And today we're going to be introducing a new lab, but we have 9 ready to go for you. The academic curriculum is a series of hands-on instructional guides that provide step-by-step instructions and include some of the key functions of the software. The lab documents have been built by our specialists here, written by our specialists here and our expert here, with help from the academic community in Maine and other schools around the country. We deliver them in a series of PDF files, so they're easy to obtain, and offer students the opportunity to follow a prescribed workflow to a defined conclusion. The lab includes exercises and the data you need, and gives them the opportunity to apply that knowledge and skill, and then there's a problem-solving scenario at the end. And Katrina's going to show you more about that today. So how do you get them? Also a very easy form online, and you just get a confirmation email, and then you're free to download the materials.
Yeah, so all of these links are right at bluemarblegeo.com/academic to find any of these kind of resources that we're talking about in the beginning here.
Yep, absolutely.
Including getting to this particular form to request the academic lab materials.
This form here, the participants must have a fully licensed version of GlobalMapper to get through the materials. So it's important that you do the request for the licensing first, as I had mentioned before. An evaluation copy of the software doesn't have all of the functionality that you're going to need to get through the steps in the labs. So it's important to get that done first. I want to go to the next one. So in all of the discussions that we've had at conferences with students and faculty and here around the office, we knew that we could do more. So last year, we introduced the Blue Marble Geographics Academic Scholarship Program. It was really exciting. We have offered students a chance to win a $500 scholarship by submitting results of a research project that uses GlobalMapper. It's open to any undergraduate or graduate student, and is going to be an annual program to encourage students to explore the full depths that of functionality that our software offers. Unfortunately, the submission is closed for 2019. But if you sign up for our newsletter, you'll get the updates and other exciting information. Last year we had fantastic submissions. It was really a lot of fun to read them all. And we announced the winner during our GeoTalks conference, which was our virtual user conference. And last year's winner was James Heslington, a student in the Surveying and Land Environmental Management program at the Camborne School of Mines at the University of Exeter. We got to talk with him. So we really look forward to next year's submissions and seeing what new and interesting ways our software is being used in the community. That is also available on our website when the new submissions open up, the same URL that Katrina mentioned before.
Yeah, so that submission will likely open around April, and then we'll be closing that in December of 2020, so this year. And we'll be announcing the winner for 2019
pretty soon.
Sometime soon. Yeah,
yep,
we're starting to read through all the submissions now that just closed in December. So
yep, some good stuff again this year. All right. Well, I'm going to hand it over to Katrina. She's got a lot more to talk about today. We hope you all have the opportunity to check out our website and look at what we have to offer. And now we'll dive right into the labs.
Thanks, Danielle. So as Danielle mentioned, when you request the academic lab material, you're going to get a zip file that contains all of the information that you'll need to run each of the 9 labs, or select out of it whatever you'd like to use. So what that includes is a folder that contains the lab instructions in a PDF format. You'll see an example here on the right side of just the cover of one of our first labs. And then it has step-by-step instructions with screenshots. Each of these exercises also has a sort of final exercise. So you can choose how you want to use that. It might be a homework assignment after you've done the lab during a class session. It might be an exam that you want to use. And we've also included kind of listed at the bottom here what we're calling a professor key, sort of an answer key to go off of if you want kind of a sense of, without having to run everything yourself, what would be the correct answer to get based on the exercise that was given. So typically what this is we have step-by-step instructions using data provided, and then they're kind of reapplying that learning, showing that they learned how to use it using a different data set. And sometimes, they might need to figure some new things out, kind of a little slightly different application of the tools that we've taught to make sure that they've really understood how these tools are working. In addition to that, obviously, is a folder containing all of the lab data kind of split up by the lab session. And most of this data is, in kind of reusable format, kind of common file formats. We really pride ourselves on that interoperability with other software. So it is file formats that you'll see throughout the GIS industry that we're using in terms of raster, vector, LIDAR data, etc. So that is what you will get. Let's take a look at an overview of the 9 labs that we have available right now. So perusing down this list a little bit, our introductory lab, I will go into a little bit more detail about later, but it is kind of a basic getting started with GIS. So it talks about the basics of raster and vector data, and also, navigating the map, that kind of basic interface. And that is kind of a prerequisite for most of our labs, or we list it as, recommended to kind of learn how to use the software. It is one of the longer labs, so depending on your classroom and kind of what type of GIS analysis you're doing, not all sections of it might be relevant to you, but I'll talk about that more later. But then you'll see down this list, we continue in with terrain analysis, vector work with attributes and thematic mapping, working with imagery, including rectifying imagery, and also, satellite imagery work with the raster calculator, so calculating things like vegetation indices. Also kind of converting between data types, so extracting vector features out of raster data. And then getting a little more into the heavier analysis, watershed modeling, creating 3D products out of UAV imagery, which is the one that we're going to highlight today. So working with drone data or UAV data. And then also working with point clouds, so 3D point clouds from LIDAR, or we'll also do some similar stuff with the point cloud we generate from our UAV images. So classifying that, extracting that. So kind of a couple of main categories here in terms of raster analysis, vector analysis, 3D data like terrain and LIDAR are included in our 9 labs that are available here.
It's really comprehensive. There's a lot here. What would you say it would take a person to get through this if they were to start at number 1 and go through number 9?
Ooh, let's see.
So it would take me months.
Yeah, so this is a pretty full load. So I think when we test this, it's probably a couple of days of full work days going through this with people that are already experts in the software.
Right.
So this is certainly, the better part of a semester curriculum.
Great.
Depending on how many classes you might have, and how many lab sessions, and how much you want to use as homework versus in class time.
Excellent.
But yeah, each of these is probably at least an hour to 3 hours in terms of the time that it would take to go through this lab.
That's great.
So before we get started, we have a couple of polls. We just want to find out a little bit more about our audience here and exactly what types of labs you're more interested in using in your classroom. So I'm going to launch this first one right now.
Hopefully you all can see that and take a
So we'd like to know, does your curriculum include using UAV data? So that is the lab that we're kind of highlighting today, and we are responding to, as Danielle is saying, sort of a growing need in the industry to have graduates that have some exposure to this fairly new technology. And we're hoping to provide that in terms of the side of taking that UAV imagery and turning it into GIS products that can be analyzed, and kind of bridging that gap between GIS users or more GIS experts, and then, some of the other side of industries that are starting to use this technology and really do need that expertise of people that know what to do with the data, or how to make the data, even how to make it a useful product.
Right, clip it down and tile it up. Sure.
So,
all right.
Looks like we've got some answers there.
All right,
great.
Thanks.
So I'm going to go ahead and close that poll. Thank you for voting. And just to guide the rest of our presentation a little bit more, we're going to ask one more question here. So we're also interested in finding out what other types of analysis you use in the classroom. As Danielle mentioned, we have a wide variety of industries that use GlobalMapper, everything from surveying and engineering to, even aviation and aeronautics now. More traditional fields like geology and geography that, have used GIS or mapping technology for a long time, as well as surveying.
Yeah. And it's growing into marketing and into the insurance industries and business. We didn't even talk about applications for oceanology, really.
Yeah, absolutely.
A lot of earth-based sciences that can take advantage of this, though. Oh, even more voters. Right. Excellent.
So we're getting some answers there.
Oh, that's pretty even. Looks like everybody is getting exposure to lots of different types of data. That's great.
So I'm going to go ahead and close that poll.
I'd leave it another minute. No.
Thanks. So we'll show you some of those answers there, just in case you're curious here. So I know that other faculty are always curious about, what's being used in other classrooms. So it does look like quite a few attending the webinar today, obviously a selective audience here, but are interested in using UAV data in the classroom, either introducing it new or they're already using it. And then the second poll here.
Hide it first. Wow.
Pretty even here in terms of the type of GIS data that people are working with.
That's great.
Pretty even numbers there.
I like to see
Raster.
Yeah, I was going to say a lot of, and even the amount of 3D nowadays seems to be growing quite a bit too.
Absolutely.
Students get exposure to that.
Great.
Fantastic.
Okay, so let's dive right in here. So I'm going to start by taking a look at our newest lab. So this lab is called 3D Analysis from UAV Images. There are 4 sections in this lab. We're going to take a look at loading in the UAV images into the software, and then running our pixels to points tool to generate a 3-dimensional point cloud as well as an ortho image. We have designed this lab to kind of be processable in, between half an hour and an hour, or actually I think within 15 minutes to 30 minutes for most, good machines to process this data. This is a fairly computer intensive process, this 3D reconstruction. So taking images, doing sort of automated photogrammetry to reconstruct that 3D scene. So we have, tried to make that so that it is usable and repeatable on lots of students' machines and kind of keep the data not gigantic here. So that means that we haven't included the 3D model step here. That is an option for you. I'll show you that in the interface if you want to include that in your classroom as well. But in this case, we're not creating that photo texture 3D model. That would take a bit longer in processing time. So rather than 15 to 30 minutes, you might need each student to spend an hour on a machine, letting the machine process. So it's up to you if you want to include that.
Sounds like a good homework assignment.
Yeah, so once we've created that point cloud, we're going to look at classifying the ground points out of that point cloud. So this particular example is really paying attention to the terrain at this farm site here. You can see kind of an example of the final result on the right side here. And then we're going to use that raw 3D point cloud data and create a digital terrain model. And then one more product, we're going to also create some contours and do some contour simplification to really make a nice additional product out of our UAV data.
This sounds like something someone would do for a job time and time again.
Yep.
Real life application.
Yeah. So let's move on to taking a look at what that actually looks like here. So the first tool that this lab is going to have you pull up is the Pixels to Points tool, where you're going to load in all of the images. So we've provided 45 images from this UAV flight. Most of these are close to nadir, so looking mostly straight down. But you will see, part of what these algorithms need to correct for is as you get away from the center of the camera, you are getting some distortion, some non-exactly top-down imagery.
And Katrina, that Pixels to Points tool is part of the LIDAR module, correct?
Yes, thank you. Yes. So actually, when you were talking about licensing, so of course, when you request the academic license, that can include GlobalMapper. That can also include the LIDAR module.
Should include the LIDAR module.
Yes, should include the LIDAR module.
I throw it in when people don't even ask for it. So.
Yes, and then you can also request the geographic calculator license as well. So especially in this context, if you want to work at all with vertical datum transformations for your LIDAR data, that kind of high accuracy transformation are something that our other product really excels at.
Right.
Transforming between different coordinate systems, etc. It's just a little plug for geographic calculator in the classroom as well. Okay, so let's go ahead and keep going with this workflow here. So we've stuck to mostly basic settings here. So we're going to generate a point cloud and an ortho image. As I said, we're not going to do the highest quality ortho image, which usually is made from the 3D model. That is just to keep this processing time a bit shorter, but we will see a good result here, and certainly something that is a product that a lot of industries are using in terms of easily obtainable, high accuracy imagery. And then some basic settings here. We're also going to reduce the image size here just to speed up this processing a bit. So I actually have a recording here. This will take between 15 and 30 minutes to process. This tool does have a little bit higher of a processing time and higher system requirements than some of our other applications. You'll see a fit error there in the dialog when it is done. There is a little bit of randomization in this algorithm, so not every student is going to get exactly the same result here. So you don't want to compare those, to be exactly the same points in exactly the same location. Part of those algorithms that do that detailed 3D reconstruction are going to, I'm just going to pause this for a second. They do include some randomization. So just so you know that in terms of grading or, helping your students, not every result is going to have the exact same number of points generated. That is kind of how we take big data and make it, usable and meaningful without spending, lots of computing time. So we're creating two products here, the point cloud and then also the ortho image. Right now that point cloud is being colorized by the pixel values, so the RGB that came out of the photo. And we can look at both of those products here. So we'll just have them turn on and off the layers and kind of explore that data. We're also going to take a look at coloring those LIDAR points by their elevation as opposed to their color so that we can get some context in terms of the height here. So you can see the sort of depression in the middle of this scene here. And then also we've got this building at the bottom edge of our scene. If you are talking about UAV data collection in the classroom, it can be important in terms of collection to make sure that you're collecting in a way that gives you the data that you want. In this case, this survey was done with a focus really on the terrain and the landscape. They were interested in knowing more about the slope of this hill and doing some sort of farming planning on the scene. It wasn't really designed to do a really good building model reconstruction where you would need to be, have some lower flights that get up under the eaves of that building and get a full reconstruction of that building. So that's to be expected given kind of how this flight was taken. Okay, let's keep going here. So then we can take a look at that in 3D. So they can really explore that scene and get a sense of what we just created. So purely from imagery that just has that GPS tag in the header, we've taken that information and processed it into this 3D set of points that we've been able to identify across those images. So the next step that we're going to do here is take a look at the classification. So because we just sort of falsely generated this LIDAR-like data, it has no classification applied to it. And we have points from all different surfaces. What we want to do is identify the ground. And we have just a couple of settings here that we're going to use. So we want to make sure that we do some pre-filtering here. So these bottom settings that are being adjusted right now, these are pre-filters. So we're going to filter out points that we know are not likely ground because they're a certain height above ground, certain height above, the maximum change in height that we're allowing in our scene. So if this is a higher relief area with lots of cliffs, we would need to kind of account for that and say, oh, the ground might drastically go up. That's probably a cliffside and not a building. In this case, we don't have a lot of that. It's a fairly flat area. We do have some steeper slopes in this area. So we have increased the expected terrain slope to account for this kind of steeper hillside. And then lastly, sometimes there are sort of plateau areas that look like kind of a big ground plateau, and it's actually the roof of a big building. So that's what that last kind of pre-filter is. Not to get too into the weeds here, but the main part of this algorithm is the settings on the top. So we're generating a best fit surface of sort of the local minimum and then comparing points as to how close they are to that best fit surface. That's how we get some ground classified points. So all those settings are included in the lab instructions. And what that is going to do is process this data and give us some classified points in our point cloud. So this is going to let us create not just what we had initially, which might have been a digital surface model, but now we can also kind of remove the buildings and trees and create that digital terrain model. So we can get things like contours, maybe do watershed modeling, etc. So now we're going through the step of creating that digital terrain model. So I'm calling it a DTM here for digital terrain model. I want to make sure I filter to just the ground points, and then we want to make sure we have a resolution here that kind of matches the expected accuracy of our data. So we're using about 3-point spacings here. Doing a little bit of averaging to get rid of some of the noise that's going to be present in this reconstruction process. And we're also doing some interpolation. So this slider that was just adjusted, that is inverse distance weighting to kind of fill out some of the holes where we might not have had points, but we still want to create a mostly complete terrain surface. So we allow a little bit of that interpolation to happen. So that is going to be the terrain surface product there. And then the final section in this lab is going to be generating contours and doing a little bit of simplification on those contours to create a nice product there. So we're going to generate 1 meter contours here. We do have some settings here for index contours. So every 5th contour is going to be a little bit bolder. Every 10th contour is going to be even bolder so that we can kind of keep track of where we are as we go uphill or downhill. So those are commonly referred to as index contours. We're also going to get rid of some of our shorter contour sections here. We're actually going to up that a little bit to something more like 50 meters. We really just want the general trend of our scene here. Those are the main settings that we need here. We're not looking for local peaks and depressions, but that is an interesting new tool.
That's a great new tool.
There are other videos on that if that's something you want to take a look at.
Lots of options to dive into in that dialog box.
So that has generated a number of contours now, and the last step that we're going to ask students to do is a little bit of smoothing here. So this would be a great place to sort of discuss perhaps accuracy versus precision, or maybe cartographic generalization in terms of our data. There is going to be some noise in our data, and we want to make sure that we're representing, what we actually have in terms of the precision of our data. So we're going to do a little bit of smoothing kind of for both of those reasons, to make it look a little bit nicer, but also to, not necessarily, we don't really know for sure that it's a very jagged exact contour line like that. So we're going to generalize a little bit to kind of account for a little bit of uncertainty in our reconstruction.
Yeah.
So that's going to give us some nice contour lines. So they can continue working on that in 3D. We'll also take a look at, turning on the ortho image here and looking at kind of how that looks draped in 3D. This is similar to what you would get if you did generate the 3D model. This is a slightly simpler version, but a similar idea here where we're taking that texture and applying it to a 3D surface. So if we want to take a look at that in 3D. Go ahead and pause that, and actually let's take a look at the application here. So a few things that didn't get included in that video. When you do process the pixels to points tool, you're going to get some statistics here. So the error in terms of each image here, we can actually get some information, kind of the number of unique features that were found in each image that made it through to our full reconstruction. If you are doing this with other data, you might find some images that aren't matching well. We do recommend 60% overlap for our imagery, so that's a good kind of industry-wide in terms of these 3D reconstruction tools. 60% is kind of a nice range to be in to get good 3D reconstruction. We didn't include in the example here ground control points, but that is something that's definitely worth talking about in terms of the precision of the data collection. There's a couple ways that you can sort of correct that. We can add ground control points where maybe we've had targets out during our flight collection and we have precise locations for that, and we can locate those in each of our images. A lot of the industry is also using higher accuracy GPSs, so using RTK or PPK positioning to get the GPS information in the drone to be more accurate. So those are also things that you might want to talk about in your classroom. And then in terms of the final results here, so we can take a look at this in 3D as well. So we will have generated a nice ortho image here, as well as the contours representing this landscape. And we can exaggerate that or play around with that data as well. And the photo draping of that building is perhaps a little bit funny because we didn't include the reconstruction of that building. We are looking at a digital terrain model.
That's a future lab. We'll work on that.
Okay, so that is the main lab exercise. I'm going to switch back to the PowerPoint here, and we will take a look at the final exercise here. So there is a final exercise where the students will be asked to kind of redo this analysis on a different data set. So in this case, they're going to be asked to, the prompt that's sort of written here in large letters. So using the provided data, create a 3D point cloud of this landfill site. And we're also asking them to create a surface model, so a digital terrain model, and contour lines that have been generalized to model this landfill site. So the topics that are being tested here or done as homework are kind of listed at the bottom here. So this would include working with that UAV data and turning it into these products of 3D point clouds and orthoimagery. They'll need to auto-classify ground points. They'll need to know how to create that digital terrain model and make sure that they do actually just include the ground points and kind of choose the best options there. What we recommend and what we do in our lab is that binning method. So we do a little bit of generalization to kind of get the best ground surface and get rid of some of that noise that is inherent in a lot of this point cloud type data. And then lastly, generating those contours and doing a little bit of generalization there to create some nice contours as another product there. So that is our latest lab.
That is great.
How are we doing on time here?
You're right spot on, Katrina.
Great. So I've got a bunch of other slides kind of covering some of the other 8 labs in our workflow here. So I'm going to spend a little bit of extra time on the introductory lab because it is one that is sort of a prerequisite, or we recommend it for a lot of our other labs.
It is a good place to start to get the basics, to feel the layout of the software, how the menus work and how the screens flow, kind of give them a little bit of a foundation before they dive into that great 3D analysis.
Exactly. So this one is a bit longer. It does have 8 different sections that you'll see listed here. And again, depending on what type of analysis you plan to do in your classroom, you don't necessarily have to have your students go through each section. Right. But they're kind of chunked into different areas here. So the first lab is going to work with loading shapefiles, managing layers, kind of reordering layers, that basic visualization, and also navigating the map interface. Then they'll move on to working with vectors. So the next 2 labs are going to do things like creating new vector features and also editing their attributes, and then adjusting the appearance of those vectors based on those attributes. So kind of basic thematic mapping. In a later lab, we'll get to sort of the choropleth mapping as well, but this is just kind of the basics of changing the style of our features. Then we'll look at some basic image processing. So the image swipe tool is a nice way to sort of do a visual comparison or visual change detection between different raster layers. And we'll also look at blending raster layers together. So things like transparency, texture mapping, kind of blending layers together to get kind of a combined result here, where we might be bringing in multiple raster type data into one kind of cartographic layer. So we can get all that information together. And then also just kind of basic raster management, so things like cropping and tiling the raster data. So that is primarily working with imagery in that case, and also things like topo maps. In the section 5 here, where it's talking about querying and filtering data, we're looking at querying attributes and then also spatial querying. So you'll see this bottom right example here is a railroad corridor, and they're actually going to be looking for the towns here that intersect this railroad corridor. So what towns would be within the service of this railroad corridor. So that's a basic spatial query. For spatial analysis, we'll also take some points and look at some heat mapping or some density mapping. So you can see that in kind of the blue image here. This is a heat map. This is looking at hospitals around the state of Maine.
Oh yeah, remember that one?
Yeah. And then we'll also look at kind of to wrap up kind of the basics of using a GIS, sharing data. So creating a GeoPDF, something that maybe a non-GIS user could use to look at some of this data. And also very basic reprojection. So we'll look at changing from UTM projection to a state plane projection. So you'll see a slight rotation in the data. And you can talk about how that is kind of affecting how we're understanding the data and maybe what compromises or distortion is happening depending on how we choose that projection. So that is the introductory lab. The final exercise in that first lab is going to be kind of bringing together some of those later spatial analysis tools. So they're going to look at hospitals around the state of Maine, and kind of they need to get a count of hospital points inside of each town, and then also create some thematic mapping here, so to visualize that data kind of across the state. And then basic cartographic layout, so they'll make a map layout and then create a geospatial PDF of that. So that is the kind of starting lab that is kind of a large introduction to different types of GIS analysis, obviously focusing mostly on vector and a little bit of raster analysis there.
Great place to start.
So that is recommended as a starting point for most of our other labs, but again, you can kind of pick and choose what parts of that you need to include. Moving on here to the second lab, we look at generating terrain surfaces and creating contours. So this is going to work with LIDAR data in kind of a basic form. This is USGS LIDAR, both the starting data set and also the final exercise is working with publicly available LIDAR data. If you are in the US, a lot of states have this available through the 3DEP program with the USGS. So that's the type of LIDAR that we're working with. And it is, about 1 meter accuracy resolution. So we'll look at improving that classification. So reclassifying what, maybe the data vendor that was given that contract did. So we might be able to improve on that ground classification just a little bit. Creating that digital terrain model out of that data. And then also creating other products like contours and shapefiles of those contours. So that kind of covers that first one. Also listed in there is cropping that data down. So maybe we don't need, the whole file extent that we've gotten, but maybe we have a particular site of interest. This image is actually from the final exercise where they're asked to kind of repeat a lot of those steps for this particular golf course site. Again, we're a little biased on the Maine data here since our office is located in Maine. Fun to work with that data.
Well, we've got some great terrain to work with here.
Yeah, absolutely. So lab number 3 is another vector lab where we're going to be looking at thematic mapping. You can see the choropleth map that is the result here. So also working with attributes. So we'll look at joining attributes from an external table, calculating new attributes, including things like, maybe normalizing data, so dividing one attribute by the area or something like that. Thematic mapping, so we will use those attribute values and apply those as a style to each area feature in this case. We also have a fun little part of this where we take a look at kind of advanced thematic mapping where we might want to create kind of a 3D representation of what those values are. So in this case, this is, access to hospitals around the state. So we're getting a sense of kind of where the hotspots are by having this sort of 3D representation of that data as well, these kind of 3D areas that are extruded in our scene. So it will cover that example as well. And then again, in this cartographic workflow, we want to practice nice map layout, having the required parts of a nice map layout, which aren't necessarily included in this example on the right, but you might want things like a scale bar, metadata, a title, etc. And then you can create a PDF product out of that as well.
Yeah, GlobalMapper does have a lot of great options for creating paper maps if you were expecting a printed result. I'm not sure which lab may dive into that.
Yeah, so this is one of them that does that. Yep. And even, beyond the kind of paper worlds, there are a lot of people out there that want access to geospatial data without full GIS use.
Right.
And we found that a geospatial PDF is really a nice way to do that. You can maintain some of that basic GIS functionality of turning on and off layers.
Right.
You can also even do some measurement now in PDFs.
Great.
Yep. As long as it's a geospatial PDF like we create, you can actually do some basic measurement.
Or if it's a group project and you need to share it amongst your group members, you can have them work on the individual layers as a team.
Yeah. And actually, within the last 3 years, I don't remember which release, we do actually read the data back out of a geospatial PDF as well.
Yes, that's right. We do.
So both as raster and as vector.
Right.
So yeah, it can be a nice across different types of GIS format as well. The fourth lab here is going to move into working with imagery. We also take a look at some online sources. So GlobalMapper has a great list of online sources built in. So you can stream in base map data, all types of reference data that you might want. We have a nice list of imagery, terrain data, some industry-specific things like weather information or bathymetric data, etc. Even some aviation charts included in our online source list. Most of those are free, freely downloadable, publicly available sources.
A lot of state GIS libraries provide free data that students could access.
Absolutely. Yep. Yep. A lot of state repositories and things like that.
And you can enter in your own source as well.
Yes. Yep. You can also add custom sources. So in this case, we're going to take a look at referencing this historic New York City Central Park map. And we're just grabbing some OpenStreetMaps data to compare it to get kind of those locations of the corners of this data, kind of a basic georectification exercise. So we'll be taking a photo that might just be a scanned map or something that has no geospatial information and actually giving it a location that will align with other GIS data. And then the last step here would be exporting that so it is a fully georectified image so that each pixel should line up with its accurate latitude and longitude. And that can be used in our software and also in other software by kind of including that information and that transformation of the data in the header and in the way that we represent the pixels in the file. And then the final exercise will also do that. So they'll take a kind of a more modern scanned planning map and rectify that against some imagery as well. Moving on to working with a little bit of elevation data and also extracting vectors out of raster data. This Lab 5 really looks at sort of multiple criteria evaluation. So we're looking at finding areas that match two criteria. And in this case, I think we're looking at areas that are high elevation and high slope. So, kind of creating those vector features based on our terrain or based on our imagery, and then also combining those so we can find kind of a best area that matches some criteria that we need. And in this case, again, we will look at a PDF export of this data. Lab 6 will take a look at watershed modeling. So this includes a watershed analysis or a drainage or catchment basin. So that's the large pink area that you can see in these two examples. In the workflow steps, we'll also do spill modeling and drainage modeling. So we'll say, if a spill occurred at this point, where is the water going to flow? And also, if we have maybe say a sample taken at this location, what is the land area that drains through this location? So you can take a look at the drainage area above a particular, maybe it's a sample or a point source pollution or something that you want to kind of get a context of what is the land area that's affecting what's measured at this location or what we're seeing at this location. We'll also do some spatial querying in this lab in the sense of finding those areas of interest that overlap that watershed. So the example on the right here, sort of in the background, we're looking at finding parcels, or property boundaries that are inside of this particular flow area. In the final exercise, they're actually looking at the entire drainage basin of the Mississippi River and finding all of the US counties that are inside of that Mississippi River drainage basin. This is kind of one of my favorite exercises here. It's a pretty cool final exercise. Yeah. And it also gets a little bit at, downscaling our data. So decreasing the resolution so that, we can do a faster analysis here, but get the right accuracy that we need for this cartographic representation, which is the whole country. We don't necessarily need to go to the highest precision here if we're just looking at kind of the general sense of which counties are inside of the Mississippi Basin.
Still a lot of data.
Yeah, so that's a really fun final exercise there. In Lab 7, we're going to take a look at working with LIDAR data in more detail. So we'll look at classifying first ground and then also buildings and trees inside of our point cloud. This is, again, USGS collected LIDAR data, so about 1 to 2 meter resolution, 1 to 2 points per square meter. Once we've classified that data, we can do some feature extraction. So we can find points for individual trees and get a sense of, an approximated height and crown width of each of those trees. We can also do building extraction, so we can kind of approximate building footprints or building models, I guess, of what those areas are, including kind of their heights. Then the exercise will go on to do some attribute querying. So using those generated tree points, we're looking at finding some of the tallest trees in this area. They'll also look at subsetting that data, so kind of taking that set of points that we've selected and moving it into its own layer that we can style differently to kind of divide our data here.
I hope we use state of Maine data for that one as well.
Yes, of course.
Plenty of trees here.
Plenty of trees. And the final lab that I haven't covered yet is Lab 8. This is another favorite of mine. This is working with satellite imagery using the Raster calculator. So we'll take a look at the different bands of satellite imagery that are necessary for this vegetation index calculation. So this is primarily the red reflectance, red range of light values, and the near infrared. And those two values help you see some information about the health of vegetation. This is one of many calculation formulas that you can do in sort of the remote sensing realm of GIS analysis or remote sensing, working with satellite imagery and band math. So we have some built-in formulas for this, but it is looking at red reflectance and near infrared reflectance to get at this NDVI calculation, which is the normalized difference vegetation index. We also look at the change detection of that. So looking at two different time periods. The blue image on the left there, we're looking at kind of change in crops over two different time periods. So kind of the beginning of the growth season and then kind of the end of the summer harvest, and you can see those changes in vegetation. And then the final exercise on this one is another one of my favorites, although very, not great and also sort of timely. This is looking at the fire areas from the Napa, California wildfires a couple of years ago. So we're looking at the final result there of finding those areas that had a massive loss in vegetation. There are some other ways to calculate that besides the vegetation index, but it does give you a nice example here to be able to sort of detect those major parts of that wildfire and where there was a lot of tree loss in that area.
Definitely very relevant for today, unfortunately, is correct.
Yeah.
Wow, that's a lot. That's a lot of
so
information.
We have some great content there.
We sure do. I love it. Makes me want to start over and do it all over again, but it's really nice to work with a piece of software and to work with the team here at Blue Marble who is so creative. The software is kind of always evolving as the industry is, so we take a lot of suggestions and feedbacks from our users to make it the great piece of software it is. We have all of these resources here that Katrina has listed to help you get started with it and to help answer your questions as you work with it. You can watch the videos, and there's shorter ones and more in-depth ones.
Yeah, there's also the Getting Started guide and the help files available in the application.
Yep.
What I didn't list here, but might be relevant for some listeners here, we also have self-training materials.
Oh, right.
So this webinar was really targeted at our academic audience and our academic labs, but we do have a similar kind of self-guided training set of labs that are exercises that are available for people that just want to learn the software and have some kind of guided instructions. So that's also available on our website.
And you could direct students to that if they cover a tool or a feature that's not included in the labs and you wanted to dive deeper into it, or if it was more relevant to the topic you were teaching on at the time. So it allows you a little bit bigger menu of tools to pick from.
And of course, we have a great technical support team.
Yes.
And that is included with our academic licensing as
Absolutely.
well. You can reach out to our technical support team.
Yep. And Katrina and I are happy to help at any time. Great. Well, let's see. Do we have any a time for any questions here?
So I'm gonna take a look here and see about there are questions.
There's a couple here. That's great. So how do we sign up for the newsletter? That's fantastic. That is right on our website as well. I don't know if we have the website open here, but we can definitely provide the information. Anything else here?
So this curriculum we have put out to have updates for version 21.1 and 21. We would like our academic users to be on the latest version.
Yep.
That being said, I think most of these tools are kind of foundational tools that have been around in the software for a long time.
Yep.
So there's just sometimes some slight interface changes that get included.
Yeah, but you can, if you have an existing license, we'd be happy to update it for you. And of course, if you're a first-time user of the software, you will always get the most recent version of it. We do try to follow up. We like to hear what you're doing with the software. We like to hear feedback from the students. Actually, we have a professor who makes that a part of his course, a requirement of his course, that the students have to provide feedback on a couple of different tools as he offers different options. So it's nice to get that feedback from each version there as well.
Great. So I think a couple of those questions that I see here, I think have been answered by our lovely tech support person that is standing by here helping. So yes. I think we've covered kind of the general questions there. Yep. Thank you very much for your time today.
Absolutely. And we do hope that you all take a look at the material and have a wonderful day.
Yeah, thank you very much.